Part A. So let's quickly fill up the table. During a collision, Newton's third law of course holds true all the time, including throughout the duration of a collision. So the momentum is going to be conserved all the time, whether it's elastic or inelastic collision. Kinetic energy, however, is conserved only for an elastic collision. For an inelastic collision, some of the kinetic energy has been converted into elastic potential energy in the deformation of the objects that collided, or sometimes into heat, and these energies are never returned as kinetic energy to the balls. So kinetic energy is not conserved in an inelastic collision. Total energy of course include all forms of energy, whether kinetic energy, elastic potential energy, heat energy, whatever energy, since the principle of conservation of energy must hold true all the time. So the total energy is conserved for both elastic and inelastic collisions. To answer part B, we first notice that the initial total momentum is 0 before the bullet is fired. Both the bullet and the rifle are at rest, so the total initial momentum is 0. And by the principle of conservation of momentum, the total momentum must remain as 0. So since the bullet gain momentum in the forward direction, the rifle must gain momentum in the backward direction. That's why the rifle must recoil. It should be quite clear that the kinetic energy is 0 before the bullet was fired, and the kinetic energy is definitely not 0 after the bullet is fired. Both the bullet and the rifle has some kinetic energy after the bullet was fired. So this is actually what is called a superelastic collision. The kinetic energy actually increased after the interaction. So what happened is actually the chemical potential energy of the explosive has been converted into the kinetic energy of the bullet and the rifle. Moving on to part D, which is the calculation part. We're going to apply the principle of conservation of momentum. Before the bullet was fired, the momentum of the bullet and the rifle were both 0. So on the right hand side, we write the total momentum after the bullet was fired. So this is the momentum of the rifle, m times negative 2 meters per second, and this is the momentum of the bullet, 0.015 times 500 meters per second. So from this equation we can solve m to be 3.75 kilogram. Easy! And thank you for using XM Physics.